Hey folks, I've had a question from some of you about this problem here, so I'd like to go ahead and work it. So this is from the section 3.9 homework, and let's go ahead and give it a shot. So we're given the function f of x is equal to the sine of x all to the natural log of 5x. And we're being asked to compute the derivative, find f prime of pi over 2. So let's go ahead and give it a shot. So in order to do that, we're going to have to compute the derivative. Let's go ahead and do that. I'm going to rewrite the original function as y equals the sine of x all to the natural log of 5x. So I'm just rewriting it as a y instead of f of x because I'm about to do logarithmic differentiation on this thing. So how does the process of logarithmic differentiation work? Well, what we do is we take the natural log of both sides of this expression, creating an implicit function. Notice that we started out with an explicit function, but we're going to take the natural log of both sides, creating an implicit function, and then use the properties of logarithms to simplify the right-hand side to make it easier to work with, and then to take the derivative through implicit differentiation. So let's go ahead and do that. Here we get the natural log of y is equal to the natural log of the sine of x all to the natural log of 5x. Well, one of the reasons why I did that is because now this power on the argument inside the logarithm can come outside of it. Remember, that's the property that says if you have the natural log of m to the r, you can rewrite this as r natural log of m. So let's give this a shot. We end up with 1 over y prime is equal to, oops, I'm sorry, before I differentiate, let me finish doing that property. So we get the natural log of y is equal to the natural log of 5x times the natural log of the sine of x. So now I'm going to take the derivative of both sides. Sorry folks, I had somebody pop in. So we're differentiating the left-hand side here, and so that would be the derivative of the natural log of 5x times the natural log of the sine of x. I switched pen colors too. Okay, on the left-hand side, we get what we always get when we do logarithmic differentiation, 1 over y times y prime. And on the right-hand side, I've got two functions being multiplied together, so I'm going to have to do a product rule. So here's my first times the derivative of the second. So there's the first times the derivative of the second plus the second times the derivative of the first. Okay, let's flip this over a little bit. So we've got 1 over y times y prime is equal to the natural log of 5x times, what's the derivative of the natural log of x? Well, the derivative of the natural log of an expression is 1 over that expression. Then we multiply from the chain rule times the derivative of that expression. Plus, here I've got the natural log of the sine of x, and now I'm going to take the derivative of the natural log of 5x. Well, the derivative of the natural log of an expression is 1 over that expression times the derivative of that expression. So we've got 1 over y times y prime is equal to, notice that this is going to simplify to be minus cosine x, so I get minus, oops, excuse me, that's going to simplify to be cosine of x. So we get the cosine of x times the natural log of 5x all over the sine of x. And over here, we're going to have plus 5 times the natural log of the sine of x all over 5x, where this factor of 5 right here came from this derivative right here. So I'm going to clean that up. I'm going to clean up this, cancel these two 5s in the next line. I'm also going to multiply this 1 over y over to the other side. And so we end up with y prime is equal to y, multiplying that y over to the other side, times, notice here I've got cosine over sine, so that simplifies to be the cotangent of x times the natural log of 5x plus the natural log of the sine of x all over x. Okay. Now, what was y? Well, y, way back in the beginning, was the sine of x all raised to the natural log of 5x. So finally, we get our answer for the derivative. Y prime is the sine of x all raised to the natural log of 5x times this long expression here, cotangent x, natural log of 5x, plus the natural log of the sine of x all over x. So this is our answer for the derivative. We can check that in my math lab if we still have that up. Here we go. And that looks fairly similar. The thing is they rewrote this part here. Sorry, it's a little hard to see that. They rewrote this part here by factoring out an extra factor of x, but you don't have to write yours that way. So this is a perfectly good place to leave your answer. If you wanted to make your answer look like theirs, you would multiply this expression right here. In fact, let me just copy this. And you'd multiply this expression right here by x over x, and then pull that x out in front of everything, so we'd end up with the sine of x all to the natural log of 5x times the cotangent of x, ln of 5x, and then we've got this new factor of x being multiplied to it, plus the natural log of the sine of x, all that over this common denominator of x here. But folks, although that's what my math lab did when it represented the solution, I'm perfectly happy with you leaving, oops, I didn't copy that there. I'm perfectly happy with you leaving your answer this way right here, looking like this. Okay? So there's the derivative. This is our answer for the derivative. But the original question, as I recall, was to evaluate the slope of the tangent line at pi over 2. So now we're going to take our answer. We're going to take our answer here and then plug pi over 2 into that expression. So we get that y prime is equal to the sine of pi over 2 all to the natural log of 5 times pi over 2. Let me scoot that down a little bit. Times, I'm going to go ahead and use this version of our answer. So times the cotangent of pi over 2 times the natural log of 5 times pi over 2 plus the natural log of the sine of pi over 2 all over pi over 2. Now what a mess. All I did, folks, was take my answer from before and plug each x, plug in for each x the value pi over 2. Now the sine of pi over 2 is 1. I'm not sure what the natural log of 5 pi over 2 is, but I know that 1 to any fixed power is going to be 1. So this whole factor right here is just 1 times the cotangent of pi over 2 is 0. So that's going to be 0 times the natural log of 5 pi over 2 plus, we already said that the sine of pi over 2 is 1. The natural log of 1 is 0, so we get 0 all over pi over 2. And so what are we left with? Once everything clears, we're simply left with, so then multiplying this together, we get 1 times 0 plus 0, and so we end up with the slope of the tangent line just being 0 at that point. So we'd say that f prime of pi over 2 is equal to 0.